Okay, so far we already learned about how to produce halogenoalkane, the properties of halogenoalkane, also the types of halogenoalkane, which is primary, secondary, or tertiary. Okay, now we are here to discuss about the uses of halogenoalkane and environmental impact. Okay, halogenoalkanes uses very variative, from solvents, anesthetic, and it can use as synthetic roles, polymers, and also for refrigerant, etc. In the form of chlorofluorocarbon. Okay, let's discuss first one by one. Okay, as solvent, halogenoalkane is very good. Why? Because it contains a polar agent. You know that it has a carbon halogen, right? And you know that halogen is very electronegative. It creates the positive and negative partial charge. So we have two different regions here, a polar section here, and the non-polar region, the carbon-carbon chains. So that's why halogenoalkane can mix with polar and non-polar organic substances, so very useful as solvents. Okay. Okay, the second uses of halogenoalkanes is as aesthetic. You know that in operation or surgical procedures, sometimes needs the anesthetic compounds such as chloroform, chloral hydrate or halotene, that can be used to make the patient sleep, for a while the surgery occur. So now you understand that, the compounds or the drugs used, for this purpose is made from halogenoalkane. Okay, halogenoalkane, not alcohol, not carboxylic acid, but halogenoalkane. Okay, the third is synthetic. Okay, the reactivity of CX bond means halogenoalkane plays important part in synthetic organic chemistry. So later on, you can see many reactions of halogenoalkane, to form another compounds, Why this is very reactive? If you compare it with alkane, which is inert, so the reactivity of CX is much more compared than the alkene, So that's why alkane first should be changed to the halogenoalkane, then it can change to many other compounds. Okay, now later on we can see what type of reactions that occur in halogenoalkane, Okay, halogenoalkane also used as polymers, this is when the halogen, attached to the molecule that also have the carbon-carbon double bond. Okay, so not the pure halogenoalkane, but halogenoalkane that attaches to alkene, such as phenyl chloride or fluoroethene, it can be used as polymer later on. Okay, and then it can also use as refrigerant, aerosol propellant, and blowing agent. This is called as chlorofluorocarbon molecule. Okay, according to your syllabus, it is specifically state that you should understand about the fluoroalkanes uses. Okay, so that's why I present this for all of you. So the uses of fluoroalkanes is as the refrigerants, The first things we call this as refrigerants. You know that if your air conditioner is not cold anymore, you should add freon, right? Freon is a compound made from halogenalkane. Yeah. So that's why the first function of fluoroalkane, this is about refrigerants. Okay, and then the second is fire extinguishing agents. Yeah, since fluoroalkane is unreactive, so it can be used to prevent combustion reaction. Okay, and then the third is propellants. Yeah, you know that fluoroalkane can be used as propellants, and yeah, so you know that, for example, if you want to kill insect, I don't want to use any any type of this, but I need you to know that the insecticides bottle, you know that we push this knob, right, and then it spray, right, it sprays. You know that the liquid here needs propellant, to make it grease. The propellant used is the halogenoalkane. Okay, so the functions of fluoroalkanes, once again, as first as uh, refrigerants, the second for fire extinguishing agents, and then the third for propellants. Okay, you can see once also about the effect of using CFCs, because this is very dangerous since it can map ozone and break ozone. Yeah, you can see the how it uh, how it destroy ozone layer. Yeah, by what's this link. Okay, my internet connections is not good. Yeah, so that's why I cannot open this for all of you. So you can open by yourself. Okay. Okay, this is what happened when we use chlorofluorocarbons. First, the chlorofluorocarbons are emitted, okay, and then reach the ozone layer. Next, in ozone layers, CFCs are broken by ultraviolet light. Okay, and chlorine atoms are released into the ozone layer, and then later on you will see that it causing a chain reactions, and make the ozone layer destroy. If the ozone layer destroy, then what happened? The harmful ultraviolet light will reach the surface of the earth when we are live. Okay, the more UV light, the more harmful UV light. That means the more possibility to have skin cancer. So this is very dangerous. Okay, because ozone layer once again has the function to prevent the harmful ultraviolet light to reach the earth. Okay, so what happened actually? Why CFC is very dangerous for ozone? Okay, first, the ultraviolet light will strike the CFC molecule. This is okay, CFCl3. Yeah, in this case, we use CFCl3, and then cause a chlorine atom to break away. This is the second process. The Cl leave the CFCl3 molecule. You know that this is a homolytic fission. So the bonds break and leave the radicals. Okay. The Cl radicals later on will attack the ozone molecule. Okay, it tried to make pairing with electrons from one oxygen. yeah, to form ClO, and then the neutral O2. Okay, you know that if ozone changes to O2, it doesn't have roles as the protect layer anymore. Okay, so that's why this step is very dangerous. Okay, and then this not stop here, since the O free radical later on can be combined with the ClO and non-form oxygen, and then the Cl radical again. Okay, so this will occur again and again. You know that this is a propagation step. Okay, since it is a propagation step, so that's why yeah, this is very dangerous. Okay, this is the reactions of how the free radical formed. Okay, in this example, I use the F2Cl2 as the molecule. So once again, the Cl that will break, yeah, the CCl will break. Once again, why not a CF bond? I already told you, yeah, that CF is shorter compared to the CCl. So that's why when UV light present, the CCl, yeah, that will break first. Yeah, to form CF2Cl radical with Cl radical. Cl radical meet ozone to form ClO free radical and O2. ClO free radical met another oxygen atom to form O2, and then to form another Cl radical. And that can be attack another O3 molecule, ozone molecule. Okay, we call this process as ozone depletion reaction. Okay, this makes the ozone layer become thin. Okay, to prevent the side effect of CFCs, scientists try to find another substance that can act as a CFC, but less harmful. Okay, the molecule called as hydrofluorocarbon, or its FCs. Okay, you can see that here we have fluoro only, not Cl. Okay, since you know that CF bond is unreactive, so will not form the fluorine free radical. Okay, these non-chlorinated compounds break down more quickly once released into the air because the presence of hydrogen in their molecules. So they never rise in the atmosphere as far as the ozone layer. Okay, so we should change the chlorine halogenoalkane with the fluoride. And also another compound used to change the CFC's role is HFE, is hydrofluoroether, okay, and are used in industry for cleaning and drying. Okay, hydrofluoroether, so chlorine does not present in this molecule. Now let's practice. Okay, let's check which statements are correct. The chlorine atoms act as a catalyst. Yes, it is true. Why? Because we know that Cl used at the first reaction and it is reappear in the second reaction. So this is a catalyst. Number two, the chlorine atoms are free radical. Yes, it is true. Okay, you know that once again Cl is comes from the homolytic fission of CFC's molecule, right? So it is a free radical. The chlorine atoms are formed by heterolytic fission of a covalent compound, a covalent bond in chlorofluorocarbon. This should be wrong. Heterolytic, so this is wrong. Okay, heterolytic will produce ions, not free radical. So 1 and 2 are correct. So B, yeah, is the final answer. How about this? Halogenated hydrocarbon or halogenoalkane have many uses. Solvents, right? Refrigerants, correct. Monomers, correct. So 3 of them are correct, so A. Please pause this video and try to answer first. Okay, are you done? If you are done, you can check the answer. CHClF2 was used as an alternative to CFCs. CaClF2 should no longer be used because it was found to contribute to enhanced greenhouse effect. Okay. Yeah, we just learned about ozone. Yeah, or we not discuss about greenhouse. But I think we already discussed about greenhouse effect in chapter 15, right? Yeah, about the layer of greenhouse will trap the sunlight. Yeah. So this is Earth. Yeah, they can pass to reach the Earth, but Earth cannot reflect it back. Yeah. So the temperature of Earth will be increases. That's the effect of greenhouse gases. Yeah. Okay, so give the meaning the term of enhanced greenhouse effect. Okay, this is because the human activity creates greenhouse gases. Yeah, increase the greenhouse gases. So makes the layer of the greenhouse gases thicker and has impact on the climate change. So how to write this? Give the meaning of the term enhanced greenhouse gases, greenhouse effect. You should state that human activity creates additional greenhouse gases. Make the thicker layer of greenhouse gases. Explain how ClF2 may contribute to this effect. How contribute to greenhouse effect? Once again, what is greenhouse effect? Yeah, prevent the heat to reflect back to the atmosphere, right? Yeah. So it will turns to the earth and make the earth warmer, right? So how contribute to the greenhouse effect? Yeah, ClF2 traps heat. Yeah, traps more heat. Traps more heat in the atmosphere, leading to greater global warming. Okay, you know that if the temperature increases, then ice at the North Pole or South Pole will be melt, right? And then float, yeah, increase the surface of the sea level, okay, and then float everywhere, okay, greater global warming. Okay, so just another environmental problem associated with the use of CHClF2. Okay, this is very simple since you know that Cl present here. So ozone depletion, right? So not only affect ozone depletion, CHClF2 also affect the greenhouse, the greenhouse effect, gives the greenhouse effect as well. Okay, so yeah, to impact for the environment. Okay, this is the last question for uses. and impact of halogenoalkanes. Please try. Okay, the answer is, I think D, yeah, since it does not have any halogens molecule, any halogens atom, I mean, so this will not destroy ozone, yeah.